Take two. All right. Take two. All right. The purpose of today's lecture is to try to give you some sense of how to do coding in Mathematica. Of course, you do not have to code in Mathematica. The reason I use Mathematica is when I was in college, that was the first language I really used. Whatever you're comfortable with is fine. You often talk about writing things in pseudocode where you just write down, here are the key ideas of what I want to do. And so what I want to do is I want to show you how you would actually implement that in Mathematica. If you want to do this in R or any other language, that is absolutely fine. Okay? For those of you who are watching at home, I apologize for the eerie hands coming in on the sides. This is the only way we seem to be able to get the video to work today. Lots of problems we could start with. I thought I would start with the problem we had from Bridge yesterday. This is a great way to advertise for the first Bridge group, which will be meeting Thursday at Mission at West Cafe at noon. After that, we'll be meeting at 1. So we talked about if you have 8 cards in trump between yourself and your partner, that means 5 trump are remaining for the other 2 hands of 13. What is the probability that one person has all 5 missing trump? So we want to write a computer code to solve that. So finding probability one person has 5 trump, 23 cards left. All right? And so we want to figure out how to write the code for that. So the first thing we can do is we can start off by saying we need to have a deck of cards. And we can have this 4 suits, spades, hearts, diamonds, clubs. We would have to have 4 aces, 1 in each, 4 kings, 1 in each, 4 queens, 1 in each, and so on and so on and so on. What you want to do is you want to make sure that you are not writing the most beautiful, perfect code possible. That's not our job. That's not our goal. What is our goal? Get the answer. Okay? Now, sometimes you might want to get the answer in such a way that it could be useful to do other things, that you might actually want to then tweak it a little bit. So you might even want to write a more general code. What's the probability if there are 6 missing trump, or 3 missing trump, or some parameter that you put in, that you can then figure out that one person has all of that? Do we care about the other cards other than the trump in this problem? No. So when we form a deck of cards, we can be very careful as to how we form it. We don't really care about things except, are you a trump or are you not a trump? So what we can do is, how many cards are in our deck at this point? Is it 52 or is it 26? I'd say 26, because at this point we don't really care about the 26 cards that went to 2 people. We only care about the 26 cards still in play. What do you want to name the cards? Trump or not trump? Okay. Later on, and this allows me to give you at least some theoretical lecture in today's class, when we talk about random variables, we will never have random variables be things such as heads or tails. You can't add a head and a tail. You can't add apples and oranges. We always want our things to be real valued. You can add numbers. So we're not going to want trump and non-trump. 1 and 0. Which one do you think should be trump? 1. And it turns out it's going to be very nice if we make 1 trump. All right, so now what we will do is the following. Okay, so deck is initially going to be empty. And what I'll do is I'll put in 5 ones to say 5 trump. And when you put star dollar, parentheses, star, star, parentheses, that means it's a comment. And now what I'm going to do is I'm going to add to deck. Deck equals append. And what's nice is Mathematica, you can tab complete commands. We'll append to deck 0. Now how many times will that add 0 to the deck? Once. So what I'll do is I'll put a for statement in here. For n equals 1, n less than or equal to, how many cards do I have to add? I'm sorry? 21. I have 26 cards total. 13 plus 13 is 26, minus the 5 that I've already put in the deck as the 5 trump. So I have to do 21, and then n plus plus, increment n in steps of 1. And then you do a bracket to end.
What is n plus plus?
So n plus plus means n goes from 1 to 21 in increments of 1. N equals n plus 1. So plus plus is a nice command from the programming world. It means increment your value by 1. We could count by 2s or 3s or 4s. Another way we could have done it is n could have gone from 6 to 26. It would be absolutely the same thing, and then that way we wouldn't have to worry about doing this difficult subtraction of 26 minus 5. And now I'll write duck. So it's executed the code, and nothing has happened. The reason is when you put a semicolon in Mathematica, it suppresses the output. If I remove the semicolon, it will now list the duck. Now, one of the things is this actually readable to you? Okay, so Mathematica, I'm having trouble having it put things in the correct font size. All right, so now we've created a deck of cards. And this deck of cards has 26, so it's not really a full deck. People have said that about me for a while. It's good enough for what we're doing. How are you going to tell if somebody has all 5 trump? So they're going to get some 13 cards. So we're going to have to find a way to give people 13 cards. How will you tell at the end if somebody has 13, if they have the 5 trump in their 13 cards?
Sums to 5.
Sums to 5. And this is why it is so nice to use things like 0 and 1. If it sums to 5, they've got all 5 trump. If it doesn't sum to 5, they don't. If you had actually put in values, ace of trump, deuce of trump, 3 of trump, you would then have to do, is the ace of trump a member of your hand? Is the deuce of trump a member of your hand? You would have to do comparisons like this. We can now bypass all those comparisons with sums. There are a lot of techniques you can do that will make things a lot easier. All right, so now what we're going to do is we're going to do simulation trump split. It's good to have suggestive names. So num_do is going to be how many times you want to do it. Module in Mathematica means I'm writing a little program. The 2 curly braces there means I'm not introducing any local variables. I am a very bad programmer. I don't mind if this is now public knowledge. I often have variables going back and forth between different procedures. One of the things that I do well though is whenever I start something, I end it. And so the bracket here means I've started the module. I immediately put a bracket over there to mean I've ended the module. Yes?
What is the colon equal sign?
So in mathematics, when you do colon equal, that means you're defining something. So when I say, x equals 5, that's a result of a computation that x equals 5. X colon equals 5 means I am defining x to be 5. So here I'm defining, I can't point there, I'm defining SimTrump Split is a function. It takes as a parameter something I'm calling num_do. And the underscore means that that's my variable. And then what I'm going to do is I'm going to initialize count to be 0. I'm going to count how many times it happens. Okay? And then for n equals, oops, and my computer sometimes jumps around where I type. So if you see that happening, let me know. For n equals 1, n less than equal to num_do, n plus plus. So I'm now going to begin and end a for statement. So the curly brace means begin, and then the other curly brace means end. And I have a bracket to mean I've started my for statement. I need a bracket and a semicolon to mean that I've reached the end of my for statement. And again, it's really good habit to always start and end what you're doing immediately. Did you notice anything about how Mathematica spaced things out?
It indents it.
It indents it automatically. A lot of good programming languages or environments will do this for you now. I have been told that there are some programming languages where indentation is actually important. If you have extra spaces in Mathematica or Tech, it doesn't matter. It will still compile. It just indents it like this to make it easier for you to see what's going on. All right, so now what we need to do is we need to somehow assign 13 cards to one person's hand. So there's a lot of different commands in Mathematica we can use. One of the things is sometimes it's not bad to have another notebook open. And if you have another notebook open, you can just be playing with it. I'm going to just increase the font size so it's viewable. If I do question mark, oh, come on, it's supposed to be large. Let's try it again. All right, so if I question mark random, and I just start doing random, why do you think I'm typing in the word random? I want a random variable. What am I trying to do? What's the goal? I want to simulate dealing. I want to somehow randomly assign the cards. What's great is if you do question mark and then start typing, Mathematica will tell you all the commands it knows that are similar. Okay, so I've got random choice, random real, random integer, random sample. Ooh, random sample, oh, that sounds cool. I wonder what random sample is. So you then do Shift-Enter to compile something in Mathematica, and it's thinking about what random sample is. And then if I click over here on the little blue thing on the bottom, it expands these things out. And so it has, here's a bunch of things. It gives a pseudo-random sample of n of the EIs. So what you can do is you can tell it how many you want it to take. So what I'm going to do now is I'm going to test before I actually do my real code. So it's always good to have multiple windows open. Try something out first. Let's look at deck. Okay, so deck has surfaces. Are people able to read this? All right, what I'm going to do is I'm going to make hand be a random sample of deck of size 13. And there we go. I can do this again. And I get a different random sample. That's all you need to do to randomly sample dealing a hand. There's a lot of people who do not like Mathematica because Mathematica is a black box, closed box programming environment. I do not know really how it's doing random sample. I can look things up a little bit, but at some point some of the nuts and bolts are hidden. There's a lot of people who have a strong movement towards open source programming, where you can see exactly what is the code used to create the random sample. Not surprisingly, certain companies want to keep their code proprietary. If you have a really efficient way of doing things, you don't want to make that publicly available so people no longer have to buy your product. So it would be a very long discussion to have and not one I want to have while a camera is active on open source versus code source. But anyways, this is all we need to do is random sample. So what I'm going to do is I've highlighted this. I'm going to go back to my window over here. And now, hand is a random sample of the deck. Okay? Now what I'm going to do is I will go back over here and I will test things a little bit. So what I'm going to do now is I'm going to do hand, oh, I shouldn't have done that. So let's do, right. So if I do hand 4, this gives me the 4th element of hand. If I do hand 3, what should I get? What should be the 3rd element? 1. And so this is just a quick test to make sure I know how to access the entries. So how many of you have programmed in multiple programming environments? I'll put my hand up this way. Oh, there, okay. How many of you have programmed in multiple programming environments? One of the hardest things is when you shift from language to language is to realize how the syntax changes. Some places double brackets, some places single brackets, some places curly brackets, some places parentheses, some places space matters. It's really good, I can't emphasize this enough, have something open and just test things out first. Make sure you know how to access things correctly. There are times, unfortunately, where the programming languages will take bad code from you and they'll still compile and run. And they'll just return strange answers. They won't always tell you, warning, you have a list. To access an element of a list, I need double brackets. You only used single brackets. I'll try to maybe interpret what you mean. So do a little test like this. What I want to do now is I'm going to sum the elements of the hand, and I'll have k goes from 1 to the length of hand. Oh, I shouldn't have, I don't know why I changed the size.
Does the list not start at 0?
So in Mathematica, lists start at 1. And so this is another issue with other languages. I think C starts at 0.
I felt like everything started at 0.
No. When my son was very young, he learned that if I told him you can do something 3 more times to start counting at 0, that he knew that as a mathematician, I would always let him get the extra time for that. Mathematica starts at 1. And so this summed the elements in hand, and it gave us 4. Now I went k goes from 1 to length of hand. Instead of doing length of hand, I know how long hand is. How long is hand? 13. Why would I do length of hand rather than write 13? If I ever change how many cards I'm dealing, that will change dynamically. Also, if I've made any mistakes, it's still going to compile. There's lots of, advantages to doing something like that. So I'll now do NumTrump will be sum of hand k. K goes from 1 to 13. So I'll do length of hand. Okay. And so now we have, compiled this out. All right. I will, since it's having a little bit of trouble fitting everything onto the screen, I will just go down to 13, just so that the code can be displayed. All right, and now we have a nice comparison. If NumTrump equals 5, count equals count plus 1. So what I'm doing now is the double equals is for comparisons. If the number of trump happens to equal 5, then we have all 5 hearts, and we increase that count by 1. We found another one, and we have another success. If not, it's a failure. Should this give me the correct answer? Yes.
It should give you the approximation of the number that you would expect.
Okay, so this should be approximately the correct answer. So we're trying to decide, is it 6.25 or was it 0.31 or 3.1%? I think those were the two numbers. Okay, so now what we can do is now we'll just put in some print statements. Print, the first one, the 1/2 model gave 6.25%. The other was 3.1%, 125% maybe. And then print, we get, and then when you do 100.0, that's going to force it to be a real number and not a ratio. I don't want to have a ratio of two large numbers. I'm going to then do count, and what do I have to divide count by? Numdo. And so this will then display what the answer is. And because this will make my mom happy, I'll put a period at the end of the sentence so it's grammatically correct. Okay? Yes?
And the print command is just like writing language?
It's going to just print it out to the screen. So now I do Shift and Enter, and I've now created this program called SimTrump Split. So now I do so now I do, oops, down here. So how many times do you think we should run this to be comfortable? 1,000? Okay. I'm also going to put what's called a timing command outside of it, and it's going to tell me how long it takes to run. All right. Who thinks it's going to be close to the 3.1%? Wow, so much faith. Who thinks it's going to be close to the 6.25? Who thinks there's a mistake in the code? %. Well, maybe 1,000 isn't big enough, right? So let's make it 100,000. Was that, yeah, 100,000. It took a little bit of time, 1.95%. And it took 1.1 seconds. So, yeah, the stuff over here, $1.13. All right, well, we can afford to go up to 1,000,000. Yeah, that should only take us about 10 seconds. Maybe just 100,000 wasn't enough. It was a little bit higher the second time when we did 100,000 versus 1,000. And this is a program that should hopefully scale linearly. 1.92. Maybe it wasn't 3.125%. What was the actual answer from last time?
3.2.
It was 3.21. Anybody know what we did wrong? Yes.
Don't you also have to say if NumTrump equals 0?
Excellent. Make sure you email me. Why do I have to allow num_trump to be 0?
Because the other hand.
Because the other hand could have all the trump. So you have to make sure you get all the cases. So in Mathematica, we could do an OR command. If num_trump equals 5, and then 2 vertical lines means OR, num_trump equals 0, then count equals count plus 1. Do I have to worry about both people getting dealt all 5? No. All right, so now, if I run this again, so I'm now running it at 100,000. All right, can somebody check, was it 3.2 last time, not 3.1? So now we're getting about 3.94%. What do you think? Now, I mean, this should take us about a minute. You know, as long as we have time to chat, computers should never be idle. All right, so I'll go up to 4 million while we're thinking. All right, you know, you can work computers to death. Yes.
Would you mind scrolling up a little bit?
Sure. So we choose randomly 13 cards from deck. And let's make sure we put in 5 trump. 1, 2, 3, 4. We have 5 trump. We put in 21 non-trump. We sum, and if the sum is 5 or if the sum is 0, we increase the count by 1. And then did we say it was supposed to be about 3.2%, not 3.1%?
I think it's 3.91%.
When we did it on class?
Yeah.
Oh, good. So we're just misremembering it. Excellent. All right. So well, if it's about 3.9%, then that looks much better. All right. So you said it was what? It was 3.91. Okay. So I forgot the 9. All right. So now we just did 4 million, and we got 3.911%. All right. So I'll run it with 400,000, which should be about 4 or 5 seconds. It's nice to know roughly how long a program will take. This is a linear program in terms of just how long it runs. So with 400,000, we got numerically 3.874%. Oh, but I didn't change. I did change the print command. All right, so we'll try it again. I just wanted to print out correctly. And so in about 4 seconds, it should finish. And it's now predicting 3.91%. If you put in the right value, we get 3.94. Is this convincing? Okay. At this point, I'm convinced with 400,000. If we go up to 4 million, this will take us about 10 times longer. This is the power of being able to write very simple code. This was not a very involved code. The key part of the code was thinking of how we want to handle things. Now, later in the semester, we might get to some more complicated things where we have to be clever and we have to worry about runtime. We got 400,000 simulations in about 5 seconds. I spent more time getting the darn system to set up and display and record. We lost 4 or 5 minutes of class for that. We made up for it by being able to run the code so quickly that we could get 400,000 tests. The hardest part was how do we want to deal with our data? And so it is very easy to be overwhelmed by features that do not matter. So we talked, I think, early in the semester about when Galileo dropped the spheres from the Leaning Tower of Pisa. Does it matter what color they are? Almost surely not, unless you're doing some small effects about the air resistance, and if you're hotter, the color of the objects doesn't matter. The shape matters. The mass maybe matters. That's the whole point of the experiment. Over here, it doesn't matter what the cards are in terms of trump or non-trump. Okay? Any questions about this program? Yes?
What was the function of the count equals count plus 1?
Sure. So what this is doing is we initialize count to be 0. And so if we want to do good coding, this counts a number of successes, of, say, 5-0 splits. And now, if we are in a situation where num_trump is 5 or 0, then we got a success. We got somebody dealt all 5 in a suit. And so we now have to increase count by 1. And so typically in problems like this, you want to have some kind of counting variable. If I did not put the point 0 here, if I just did 100 times count, and then I went and ran this again, this should take about 4 seconds, and you should see the difference. And we get the answer 7,813 over 2,000. To me, this is not that meaningful. And then you just have to do some addition. This is why you typically put in the 0.0, because that will convert it to a real number and not leave it as a rational number. So Mathematica will try to work with things in as much precision as possible, as long as possible. If you're having any trouble, it will just keep displaying and it will keep chunking. Frequently, you don't want that at the end, and so you just want to think about how you want to format the data. Okay. Were there any other particular problems? I've given a bunch of them to look at that people were interested in. If not, we can just start doing some random problems. We can do the king problem from last time. You know, what's the problem? What's the probability somebody is dealt exactly 2 kings? So how do you want to do this? So, okay. So being dealt exactly 2 kings. Which do you think is easier, being dealt exactly 2 kings or being dealt at least 2 kings?
Exactly.
No, at least, because there are more possibilities.
But just setting,
For the simulation, which do you think is easier?
Oh, aren't they the same?
They're the same. If I wanted, what value do I assign a king? What value do I assign everything else? How do I determine if I have exactly 2 kings? Does it sum to 2? How do I determine if I have at least 2 kings? Does it sum to greater than or equal to? So the only difference is I have to type greater than or equal to versus equal. So strictly, yes, exactly 2 kings is slightly easier. The amount that it's easier then is not significant though. Okay? This is the power of having the correct way of looking at things. The more of these problems you do, eventually the more tricks you amass and the easier it becomes, and at some point it becomes fun. Okay? So all we want to do is we want to read out exactly 2 kings. Okay. So I'll comment that out. So let's assign the deck to be, we'll start off with 4 kings, and then for n equals 1, n less than or equal to how much? 48. n plus plus, deck equals append to deck 0. Now what if I cared about being dealt, 2 kings and 2 queens? Would that be a lot harder to do? Yes?
you could have the queen be 0.1.
Good. I'd actually rather go the other way to have the queens be 10. And so if you have the queens be 10 and the kings be 1, if you look at the sum, the 1's digit in your sum is going to be how many kings you have. The 10's digit is going to be how many queens you have. So if you actually change things by magnitudes like that, you can actually make it very easy to see how many kings and queens do you have. So there are games you can play like this using properties of the integers. All right, so we have n goes from 1 to 48. This is now going to form a deck of 52 cards. So now we're going to do king question. Will be a function of numdo again. So module.
What is numdo exactly?
So numdo is going to be my input parameter. It's going to tell me how many times I want to do this. So do I want to do it 1,000 times, 100,000 times, 1,000,000 times? Yes.
Could you just use like T, the letter T, instead of writing out numdo?
Absolutely. It's what do I want things to be. I want things to be descriptive so that when I see the variable name, I know what it means. Numdo. I wonder what numdo is referring to. Oh, maybe it's the number of times I'm supposed to do this.
What's the underscore?
So the underscore in Mathematica means this is a variable. This is a free quantity you're putting inside. Yes?
Also, what's the module?
So module is, this is the start of a function environment. I'm defining a procedure. So it's basically, it's a collection of steps that I'm going to execute all at once whenever I type king, queen, king, q. King question, yes.
And why is it like colon equal sign?
So the colon means it's defining. So if you just do an equal sign, you just say, if, alright, so since today and yesterday was Yom Kippur, I have not followed baseball, but I can now find out, does anybody know what happened in the Red Sox game? Anybody know what happened with the Red Sox yesterday? I haven't been able to look up because of Yom Kippur. No, they lost. Does anybody know how many runs we scored?
3.5.
I'm skeptical, but I will accept the fact that the Red Sox scored 3.5 runs yesterday and lost. I believe the lost part. So if you look at how many runs the Red Sox have, Red Sox runs equals 3.5. That's the value it happens to have yesterday. But in general, Red Sox runs could be a free parameter. Okay, when you use equal sign, you're talking about the current value. When you sign colon equal sign, I'm basically making an assignment. This is a definition.
What does the append do, or append to?
I'm sorry?
What is the
So what append to does is it takes dec, and it's appending to the list. Dec is a list. It's appending to dec 0. And so we've started off, dec is not an empty list. I could have started off with dec as an empty list. And I could have done the following. So I initialized dec to be empty. Then I could do for n equals 1, n less than equal to 4, n plus plus, dec equals, append to dec 1. And so what I'm going to do now is I start off with dec as empty. I then put in 4 1s to represent the kings. Then I put in 48 zeros to represent the non-kings.
Okay, I see.
And so these are lists. So I'm going to call a new function or new procedure q for king question. Numdo is going to be the number of times I want to do it. I'm not going to have any local variables. I'm a bad programmer, but a good person. I have brackets to mean I'm beginning and ending, and I always put my end bracket immediately so that I know things are already blocked off. Yes?
For the second for loop, should I do from n equals 5?
Doesn't matter. It's just a dummy counting variable. It's just going to count, it's going to execute this line 48 times. If the value n came in here, it would matter, but I'm just counting something 48 times. I could count from 5 to 52. And in fact, if I count from 5 to 52, in terms of just trying to interpret what we're doing, it makes it a little bit more logical. So there's many ways of writing the code. All right, so I have a module, so I'm going to initialize count to be 0. This is going to count the number of successes. Number of successes. Okay, and now I'm going to have my procedure again. So I'm going to go for n equals 1, n less than equal to numdo, n plus plus, begin, and end. And sometimes you might even put like over here, end of n loop, just to remind yourself when you're coding exactly what's going on. Okay, I've just ended my end loop. All right, how many cards are in my hand? 5. So I want hand to equal random sample from deck and choose 5 cards. And now what I will do is value will be the sum of hand sub k. K goes from 1 to length of hand. Okay. And so that will count how many kings I have. Well, is value a good name? Is that descriptive? No. Let's do maybe num k for number of kings. Or better yet, maybe num king. And instead of doing length of hand, we know the hand is going to have length 5, so I'll just put that in here. Again, this is just to save space for the people who are watching this at home later. Okay? So now I have I've chosen a hand of 5 cards, I've counted how many kings, and now I just have to make my assignment. So now, if num king is greater than or equal to 2, count equals count plus 1. I could have also just done count plus plus, but this is a little bit clearer as to what's going on. So which problem have I just solved? At least 2 kings. Yes?
So if you were doing the queen problem that you were talking about before, how would you account for that?
So what I would then basically do is I would be asking things about the size of my value. And so I could look at the 1's digit, and that would tell me how many kings. I could look at the 10's digit, and that would tell me how many of the queens.
So how would you do that in code?
That would take a little bit longer. One of the things you could do is you could check and see if the number is greater than 20, then I have to have at least 2 queens. And then what you can then do is you can subtract, you can then just look at the 1's digit. So look at take your number mod 10, and now you're left with the ones digit. If that number is greater than 2, then you have at least 2 kings. And then that would count how many times you have a hand with at least 2 queens and at least 2 kings. So this is where you start using mod arithmetic, start using more involved things like that. If you don't know the advanced math stuff like this, I've never taken abstract algebra myself, you can bypass this with more painful coding. If people are interested, if people want really good practice for coding, in previous years I've had Project Euler lunches where we get together. Project Euler is a phenomenal website of extremely challenging problems. They start easy, they get very hard very quickly. The goal is to write a computer program to do them in a minute or less. And it's a mix of knowing a lot of mathematics as well as knowing some coding theory. And again, if anybody's interested, I'm happy to chat and discuss stuff like that. Yes?
Can you explain what the sum function's doing there with the hand? And
Sure.
the
What this is
K?
doing is it's summing. Read it as well. It sums. The variable k goes from 1 to 5. And it's just adding, and this is my summand. This is my a sub k. It's hand of k.
So,
It's doing hand of 1 plus hand of 2 plus hand of 3 plus hand of 4 plus hand of 5. It's adding the 5 values in your hand.
okay.
So the list is called hand. The list hand has 5 elements: hand 1, hand 2, hand 3, hand 4, hand 5. And the sum takes the elements in hand and adds them all together.
So you get like your hand has value 2, which means it has 2 kings.
Exactly. And so now if num king is greater than or equal to 2, we have 2 kings. Let's do exactly 2 kings. So we're going to replace the greater than or equal to with double equals. And actually I just realized that we're doing a comparison here. So the greater than or equal to and the double equals actually have the same number of strokes on the keyboard. Sorry, I can't say typewrite anymore. They're both equally difficult code to write. All right, so now we're ready to compare our answer. So print theory says, and then it should be binomial. We had 4 choose 4. I'm sorry, 4. We got to choose 2 kings. Was 4 choose 2. Binomial. Then we had 48 cards, and we had to choose 3, right? And then we divided by binomial 52 choose 5. And I'll put the period so my mom is happy. Is that going to give us the probability of having exactly 2 kings? Yes. It's not going to display it in a nice way though, so I'll multiply by 100 to be a nice percent. Okay. Now we want to print what we observe. Print we observe, and so it'll be 100 times count over numdo. So we're calling it a king question. Let's do it 1,000 times. And we'll put in a timing just so we know how long this is taking. So let's see. Okay. So we did it 1,000 times. Theory says 3.99. We got 3.9. And it took 0.03 seconds. Well, this is taking so little time. Let's bump it up. Let's do 100,000. Didn't even take a second. We get 3.96. All right, so we'll do 1,000,000, and we'll stop at 1,000,000. So this should be under 10 seconds. It was 0.68 seconds to do 100,000. It should be about 6.8 seconds to do 1,000,000. You're seeing 6.63. Why is it not perfectly linear? Well, my computer has other things going on in the background. Sometimes fluctuations went on, but it's approximate. You can see it's increasing by a factor of 10. If we wanted to then change this to do at least 2 kings, all we have to do is change the equal to greater than equal to. Okay. Any questions on this code? So this is the level at which I want you to be able to program in this class. It's essentially going to be 4 statements, maybe a couple of while statements. You'll have some kind of list. You'll be pulling in elements from the list. I'll want you to be able to have some kind of counting. There will be math theory in this, though, is what is the best way to set up the code. And again, if you really think about things cleverly, you can make your life a lot easier. Anybody play Sudoku here? or do Sudoku. Some people may not consider this a sport. Okay. My wife and my mother do not like the way I do Sudoku. I wrote a Mathematica program to solve them. And to me, the only interesting part of Sudoku, it's not to go through and say, okay, I have a 1 here, let me cross out all these 1s. This is mindless, tedious, grunt work algebra. I have a PhD from Princeton in mathematics. You know, I should not be doing tedious stuff like this. Now, unfortunately, I don't typically have an undergraduate traveling with me on the plane to do that grunt work for me and then hand the Sudoku back to me, so I wrote a computer program to do this. What did you have to do in a Sudoku? Yes?
You have to get it so every row, column, and box adds up.
Oh
Has
dear
each, so-
God, has each, you have to have a 1, a 2, a 3. So we have to check and say, does each row have a 1? Does each row have a 2? Does each row have a 3? Isn't that going to be a pain? You're going to have to use functions like member Q. Member Q, what's that? Well, let's go over here and let's type member Q. Or we start typing member, gives us member Q. We click on this over here, and this will tell us how you can tell if something is in a list. So member Q works by you input a list and then you input your quantity. So for instance, hand is the following. I could now type over here member Q hand 0. Is there a 0 in our hand? The answer is true. Is there a 1? True. Is there a 1.2? False. So you can start using the member Q command. If I'm doing Sudoku, I have to check and see, does each row have a 1, a 2, a 3, a 4, a 5? Then I have to do this for columns, then I have to do this for boxes. This is not pleasant. I don't want to do all these checks. Does anybody know how you can avoid doing all the checks?
True, sounds to whatever it's supposed to sum to.
The problem is, so you can figure out it's supposed to sum to 9 times 10 over 2, which is 45.
There are multiple.
There are multiple ways to get to 45. You're on the right track, though. So we're going to start the bridge lessons on Thursday. Can somebody name the suits in a normal deck?
Club, spades, hearts, diamonds.
Club, spades, hearts, diamonds. Normally you go spades, hearts, diamonds, clubs. But those are the 4 suits. If we change the suits to cauliflower, broccoli, carrots, and chocolate, would it matter? No. If you don't have experience in cards, would it confuse some people to start to see the 3 of cauliflowers? That's a psychology question outside the realm of this course. I think it would actually confuse a lot of people who aren't that skilled if they now see a little bit of a change. For regular bridge play, fine, I have cauliflowers. Not a big deal. In Sudokus, what numbers do you use? Why? Couldn't we do 0 through 8? I mean, we've already had that. Why do we use 1 through 9? We're used to it. Instead of using 1 through 9, what if we used 1, 10, 100, 1,000? The only way we could have all the numbers from 1 to 9 now is if the sum was 1, 1, 1, 1, 1, 1, 1, 1. Assuming I put in 9 ones. And if you do a trick like that, all you have to do is check and make sure is your sum the following. And you can bypass all the member Q relations. So there is frequently the advantage to make your coding a lot cleaner if you can find a better way of representing it. At the end of the day, do we care if we use the numbers 1 through 9? No. How many of you have ever played the game 2048? How many of you have ever played the NESCAC version? Which tile is the 2048 tile in the NESCAC version? Williams, of course. And which one is the 2? Amherst. So now, is there any difference between playing 2048 with the NESCAC schools as playing with the regular tiles? No.
Well, it says that Williams is the best.
But when you're playing it, it's sometimes hard to remember, okay, now which one, what is the ranking of them? When you do 2, 4, 8, 16, oh, which one is the one above 16? We're pretty good at that. We're pretty good at just quickly looking down and visualizing it. How you present things matter. And there is a reason why I'm spending so much time highlighting these points. Okay? Fundamentally, it doesn't matter. It is so easy to get caught up doing things that you don't need to do. At the end of the day, all we care about is solving the problem, or maybe solving it in such a way that we can then solve future problems. Okay? So I hope between the coding we did today and then what is online that this is enough. If people do want to meet and do more stuff, I will be in my office this afternoon. I will send details about the additional session. All right.